and my name is Idit Levin, and I'm the founder and the CEO of Solo.io, company there in Boston, Massachusetts. And we're working very close with the Hashi guys. We, for instance, was the team that helped them integrate Envoy to Consul Connect when they announced it. So we're working a lot of years on Envoys. We are contributing to Envoy, and we're working very, very close with the Hashi team. So let's talk a little bit about the problem that we're trying to solve. So the way we're looking at this, and every customer that we have, they're all trying to do this, which is basically some transformation journey. And they all, with no exception, starting with one thing, which is they want to move from monolithic to microservices. They want to somehow modularize their stack. And if you think about it, this is what HashiCorp is all about, right? I mean, if you think about every tool that HashiCorp has created, they're all targeting exactly that problem, which is we were monolithic, now we're microservices, everything is distributed. How do we fix the next problem? So we're kind of like in that point really, really nicely working with them because we're fixing the other problem that they're not fixing. So that's the first thing that the customer will realize, that the problem of actually migrate monolithic to microservice is not only by actually rewriting your application. Actually, that's where the problem is only beginning, because then what kind of happened, you just created a distributed application. And distributed application means that everything is happening on the network. So if before that you have a monolithic application and has an API on top of it, and you had only one place that you needed to manage this API on this monolithic, now all this monolithic is cut into way more pieces, and you need to manage all those API. And by managing all this API, it means that you need to make sure that it's secure. You need to make sure that you can see what's going on. You need to make sure that there is that it's routing, right? And you can actually replicate it and create replications of instances and scaling that you need. So what customer will understand that they will have way more problem than just actually migrating the code. So that's the first problem that they will have. But then they will discover that it's actually more robust than that, because it's not only on the API level. Now, all the communication between two microservices are on basically API, which means that now you need to manage that. So how do you make sure that something really simple, like two microservices, will be able to commute to each other? How do you make sure that they're going to do it in a secure way? How do you make sure that when you're getting a request to these microservices, you understand what's going on? Almost care why it fell. Is that was latency? Is that on the pipe? Or maybe it's actually on the microservices itself. The three problems that I just described, which is routing, security, and observability, is a problem that's being solved today with Service Mesh. And Hashi has Consul Connect, as I said, big fan, so it's great. But that's not going to be the end problem, because what you will discover is that most likely you will need to manage more than one service mesh. Probably you will need to have a multiple service mesh. For instance, let's just take the simple example. Today, HashiCorp announced together with Microsoft that Microsoft is going to give Consul Connect as a service. This is great. But if you want to do the same thing with Amazon, you will need to use something like AppMesh. And if you want to do the same thing in Google, most likely STL. So how do you connect those environments is a question. And it's a question that we need to work. So we specifically as a company, that's the problem that we are tackling, besides the problem of API gateway. So that's kind of like one of the things that we will talk about it today. The last one is that I'm a big fan of service mesh. But in my opinion, the advantage of service mesh is not only those three problems that it solves. That's where it's only start. So routing, security, and observability is the first problem, and probably the most attractive one that people want to fix. But actually, there's way more to it, because what we just did in this special architecture, we abstract the network. And if we're abstracting the network, there is way more we can do. For instance, debugging the application. We can actually do some security, very interesting stuff. We can do canary deployment. There's a lot more we can do because we abstract the network. And this is where we believe that the service mesh will go behind. So that's kind of like in the nutshell the thing we see in the market. So let's kind of like, again, iterate on the problem, start seeing some demos, see how we fix it, and hopefully, Okay, the problem itself. So as I said, microservices, big fan. Everybody needs to use it. We actually solve tons of problems by actually going and actually have microservices. The productivity will go way faster, right? The agility of your team, it's just amazing how fast we can put stuff in production. The design is the right one. It's kind of like a separation of concern, which is the right way to do this. Encapsulation, flexibility, all good stuff. But like everything we're doing in this market, we're solving one problem and we're introducing a lot of new ones. And this is exactly the problem that we created. Complexity right now. It's really hard to understand the state of the application. It's spread it all over around, you don't know where it is. The second one is the performance, right? You have network right now involved. Is there a latency? What's going on there? Where is the problem? Cost, right? I mean, now you need to buy more tools like ours. so you need to pay more money. And the last one is the testing. How do you test something? So if before that what you did was a lot of unit tests and a little bit of integration test, now most of the stuff that you're doing is integration test. Okay, so again, maybe you know that I'm iterating a little bit just to make sure that everybody's talking the same language. This is what monolithic application look like, and what we did, we just basically created an ability to have a lot of microservices. The application itself now built from a lot of microservices. This is great, but this is a very simplified problem, right? Here is how it really looks, right? And this is what people are actually doing out there. That will be you, right? This is what you will do very, very soon. And the question is, how do you manage that one, right? 500 plus microservices in production. Problem happened. Where are you finding the problem? And that's actually what you see in Twitter, stuff like this, right? And this is true, right? It is true, right? People actually don't know what to do. So again, all the problem that we're doing, we solve it a lot, and now suddenly you discover new tooling. So if before that, metrics you did with some APM kind of like tooling, now maybe Prometheus, right? Because the scale is way bigger. Logging, same thing. Before that, here's the monolithic, it's on your node, just take the log. Now, the logs is spread all over around. You don't even know where to take it from. And it doesn't make sense, the correlation, because there is so many replication of the same instance. Go figure out where your request is actually landed. So you will need something like open telemetry, or on the old name, open consensus, or on the old name, open tracing. Anyway, it's a little bit politics in this market, but basically the idea is tracing, right? It needs to be a transactional logging. When the request is coming, I need to put some idea and actually follow it, that it will make sense after it. Debugging, so native debugger, right? I can just attach the debugger. Are any of you actually debugging microservices today? No, right? We're troubleshooting, we're writing prints. We never actually debugging it anymore. It's troubleshooting. So that's one of the things that we as a company solve. We created a project called Squash that basically orchestrates the debugger for you. So we can actually attach debugger to each of the microservices and step 2. It's an open source, so you can go try it. Architecture, so it's the difference between SOA or microservices. Deployment, there's options. And testing, again, now way more if your testing actually is going to go to integration testing. So this is how it looks. And now the question that we ask is, how do you actually manage all those API? You want one place to be able to set up all the security policy and so on. You don't want to spread it out right now in all your microservices. It's just too hard. And how do you make sure that this team is actually forcing it? Doesn't make a lot of sense. Same thing with security, right? You need to make sure that everything is secure. Zero trust networking is probably the buzzword right now. We need to make sure that everything is like we don't know where it's coming from, we don't know, it's in the network, and you need to suspect everything. And then observability. So that's good, and that can be managed on the edge. API Gateway probably can do a very good job about it. But now, once it's actually going inside the cluster, again, now this problem is continued, because now you have actually the ability between two microservices, what's called east-west traffic should be also secure. Also need to be, to set the routing, and also you need to actually make sure that you can see what's going on the cluster. And now imagine that you're doing it over cloud, right? Imagine that you actually, like we have a lot of customers, one of our customers is actually a big telco organization, and what they want is to do a canary deployment, right? But I want to make sure that they're doing it in 3 data centers. And if the first one succeeds, the second one succeeds, but the third one failed, they want to roll back all of them. So this is an example. Now everything is way, way more complex when you're talking about multi-data center. Let alone if you're taking this application and spread it all over around. So that's become very, very complex. And this is why we created Gloo. That's kind of like Gloo, like its name. This is why we called it. So we believe that there should be a new API gateway that exists out there. First of all, companies, like everybody want to go service mesh, but service mesh is actually a very complex solution. And a lot of the time is even not necessary. So a lot of the stuff that we see in the market is people are starting with API gateway. And this is why, for instance, we're very popular right now, because people are interested to start with Envoy, because Envoy is this building blocks of every service mesh today, minus Linkerd. And besides that, most likely they will want to, it will be easier for them to start on the edge, but they want to fill the Envoy. They want to fill it and see how it works, that they will be able to extend that. So that's why we built Gloo. So we will talk about Gloo, and then we'll see how beautifully it is working to actually with all the stack of HashiCorp. So in the nutshell, what we did with Gloo is a control plan for Envoy proxy. Its job, as I said, is that to glue those environments. This is why it's named. So if it's you have instances of OpenStack, a EC2 or whatever you need, if you have some services or if you have even serverless, you want to glue those together. You want to make sure that you will be able to manage that. That's probably one of, I think, the only tool out there for that. Okay, so let's look at this and understand what's special about this architecture. We'll see a little bit how it's working beautifully with everything that exists there, and then we'll talk a little bit about the, it's working seamlessly with the architecture of Hashi. So basically, the architecture of Gloo is very, very, very pluggable. And in purpose, we build it that way. My background is coming from a lot of, I had a startup called Dynamic Corp, got acquired by VMware. This is what we realized there. And what we learned there is that there is no such a thing, the same customers. You already have investment in, previous tooling, and we should embrace that. We shouldn't just throw it away. That's never working. And therefore, what we did, we understood that everything should be pluggable. So that's how the architecture of Gloo is working. Gloo is basically watching. It's pretty dumb. He's just watching, and he's watching three things. He's watching your environment. And that means any environment that we want, and this is also pluggable. So if you want to create your own environment that I don't know about, you can actually plug it in. In that case, it also can discover from Consul. It will discover your Kubernetes instances, your VMware instances, EC2, whatever you need. The second thing that is watching is the secret. And for that, it's watching today two options. One of them is the Kubernetes secret. So every time that it's being rotated, it's getting it, you understand what's going on, you can send it to Envoy. And Vault, right? So that's the two things that we are watching. Every time that something changes, we know about it, and we know how to update the snapshot for Envoy. And the last one is the configuration of the user. And we're natively running on Kubernetes, which means that we are using what's called CRDs as the storage for it, which means that you don't need to do backup of active Cassandra cluster like you should have done with the legacy API so far, API gateway. But the beautiful of Gloo and how we build it is that you don't have to do it in CRDs. You can do it and use Consul as a storage, for instance. And if you're using Consul as a storage, that means that you don't need Kubernetes whatsoever. You don't have to. You can if you want, but you don't have to. So we have a customer that's using both. They're using Kubernetes and they're using Consul together and Gloo and manage them all together. And of course, it can be anything else because we built it seriously. It's like, I'm a technologist, as you can assume, and it's a piece of art. Go look at the code. It's beautiful. It's all written in Go, and we really focus on it a lot. So again, what it is, it's open source. Okay, first of all, go look at it. Okay, so Gloo, solo repository. The second thing, as I said, the discoverable is basically something that it's totally pluggable. The storage is pluggable, which means that you can use whatever environment you want. But what is more important, after we discover something changed because we are watching it, if something changed, we're getting this information, we're sending it to a plugin system. And what's going on in this plugin system is that each plugin knows to take this language and translate it to an Envoy snapshot. And then Gloo is aggregating everything is back and sending it to Envoy. So it's really strong and giving us the ability to actually extend our platform to a lot of use cases. And to be honest, this is why we're getting so many customers. The reason we're getting customers is because they're getting a tailor-made solution. Exactly what they want with the technology that they want, and they're pretty overwhelmed of how quick we're giving them the result. So that's the honest to God reason. Okay, so this is great. So let's talk about right now Hashi, because as I said, big fan. So if we're talking this Gloo with this architecture that's really flexible, that means that you can use Consul, right? You can actually use Consul as a storage. Everything in Gloo is declarative API. You're telling me what you want, and we're going and making sure that it's consistently will happen. Eventually will happen, and as I said, you don't need to backup and so on. So Consul can use as storage not only as a discovery source, and I think this is beautiful. The second one is that you can run on Nomad. Why not, right? You can use as your ingress to Nomad. As I said, we're always watching, so it's always in sync. And this is beautiful. I'll show you them in a second. You will see how quick it's happening. And the last one is that we're also watching your secret. So that means that every time that there is a rotation, we know about it, we're sending it back. When the request coming to Envoy, we already know to pack it on the header and basically create, I don't know, an action with AWS Lambda, for instance. So you don't need to worry about that. And that's really seamlessly to the user. And something happened. What happened? OK, I don't know what happened. OK, so Envoy. We talk about 1 second on Envoy. I think that people talking about it, how important piece of the infrastructure it is for a good reason. It's really, really good. So the first one, the reason we chose Envoy, the first one is the performance, right? I mean, most of our customers are evaluating versus another API gateway, and they're just amazed from the result. The second one is extensibility. Like Gloo is extensibility, and by the way, Gloo is extensibility because of Envoy, because we knew that this huge ecosystem of Envoy will go and add so many stuff. And that was really, really important to us, that we will be able to offer our customer that really quick. So we needed this pluggable system. So again, extensibility. You can actually, on the request card, plug in what's called filter, and the request is coming, and you can extend it. We specific as a company, that's basically our differentiator. That's why it was important to us. So we just announced a WAF filter. We just announced a transformation filter, caching filter, and AWS Lambda filter. And the reason is because that's, as I said, that's a huge advantage. Community, we talked about it. This is what everybody's using today for service mesh. So guess what? We, as a contributor, as well as other, can go very fast as a community. You can actually, eventually, and this is very beautiful, not like in Nginx, for instance, it's not a static file anymore. You can actually have an API to drive the configuration of Envoy. And specifically for us, a lot of the use case that we are handling is migration from monolithic to microservices. And that's the reason that Envoy was built actually from the get-go. Actually, Matt Klein built it in Lyft. Before that, he was building it in Twitter. Before that, he was building it in Amazon, exactly for that use case of migration and kind of like Gloo in those environments. So for us, there was no brainer. That should be the proxy that we are choosing. So security, we talked about it. I will be honest, this is the most important thing, right? I will pay everything to protect my keys. I'm sure you will pay everything to protect your application and your environment. That's, people not, this is something that people are actually outsourcing because they want to make sure that it's being dealt very well. This is the feature that we have for Gloo. So first of all, authorization and authorization layers, so basic code, DEX, OpenID Connect, widget, widget, basic, like implementary JOT, API keys, custom mode, everything working, tested, very, very solid to give support for your application. We're also doing stuff with policy. So like OPA, which is Open Policy Agent, one of our customers, big of the use case that they're having is basically the ability, they are a dentist work, maybe I should say. and they're basically managing a lot of dentists, and what they want to make sure is that the backend service is always returning everything, including the license of the doctor, the dentist, but they don't want to expose that to everybody, only to some people, right? So what they're basically doing when the request path is going to OPA, it's returning an OK request, but it's also telling you which field this guy is allowed to see. And then it's going down. And when it's getting down, the server itself, the backend itself, returning all the field, and we are filtering it and bringing it to the user. So you don't need to put this information to your application. Don't change them. It's too complex. Our back, of course, kick log, integration, cores, and delegation. That's very, very important. This is a new feature that we just announced. Really excited about that. Is the ability to have actually ability to delegate the domain to someone else. So basically, let's say that I'm owning solo.io, but I want to give my marketing the ability to manage their domain. So I can delegate the solo.io/marketing to my marketing team, and they can do whatever they want. And then they can delegate it to somewhere else, and so on. So it's basically kind of like giving you the ability to delegate inside your organization. WAF, really excited about it. I don't know any way that anybody has an Envoy-based application that's supporting WAF. We do. So more security, again, is available in Gloo. Rate limiting for, again, DDoS protection, circuit breaking, very important. And the last one is encryption, of course, MTLS. Let's encrypt MTLS upstream and downstream. Make sure that it's all working nicely together. Oh, we're on time. Okay. Sorry. We'll go maybe faster. So, I mean, we integrated with everything that exists there. I'm not going to, I will show you a demo. I want to show you a demo. I think it's really more interesting. But everything that you want to do Gloo, we basically can do this. And we also, if you are interested, you can actually go, and if you care or interested in Knative, Knative is a serverless implementation from Google. When they open sourced it in the beginning, they depended it only on STO. They got a huge pushback from the community. And the reason is because it's not needed. If you think about what Knative needs, it needs a good ingress. That's all. It doesn't need a service mesh. So it's like, I'm asking someone to clean my room, and the way it's doing is just bumping everything. Yeah, it's clean, but you don't need to do that, right? It's way more complex. So they actually reached out to us, the Google guy, and we were the first official implementation with Knative to, and every feature that STO is supplying to Knative, we are supporting as well. So go try it. It's pretty, pretty simple and easy. Okay, so we'll see demo. I don't need to show you those. So let's see a real quick demo how it's going to work with HashiCorp stack and with Kubernetes. When my computer will come to life again. Okay. Okay. Someone calling me. Sec. Okay. Awesome. So we will start with the HashiCorp. Yeah, let's start with the HashiCorp one. So let's see what we have here. The first one we will do, we'll open it. So let me just give it 1 second. I'm going to prepare my demo. It was a sec. Cut. Let's do 1 sec. I'm opening everything. Okay. So you should look familiar with this, right? So what we have here is Nomad, right? And we don't have any job right now. What we have here is Consul, clean Consul installation. And we have here is Hop, Vault, and we have that here. Okay, so it's pretty, pretty simple. The UI of Hashi, we didn't change anything. So what we're going to do right now, we're going to do something really simple, which is going to install Gloo on Nomad. And again, the storage will be in Consul, and it's going to watch Vault. So it's kind of like all the stack working together and basically give you this ability to manage that. So let's do this real quick. So the first thing that we're going to do, I'm going to put the command that I need to run. Okay, so the first thing that we're going to do, we're basically going to do as event, which is basically the Helm for Nomad. And that's the only thing that I'm going to do. I'm going to basically install. So what we can see right now is that immediately we got a job, right? There is 4 instances that it's running. Let's go look here. And what you can see is that there is 4 containers that Gloo is coming with. It's very, very important to us to separate the control plane from the data plane. That's the right way to do the API gateway or anything else. So what you can see here that you have the actually proxy itself, which is Envoy in our case. There is the Gloo, which is the basic. This is our intermediate language. It's basically way more low level than we hope people will use it. And then there is the gateway itself, which is bringing all the beautiful of API gateway management and much more makes sense. And the discovery that we talk about, we're discovering everything that exists, we have that. So again, the discovery is going to console and basically discover everything we have there. Okay, and as you see, it's installed, so it's great. Just to show you the demo, I'm probably also going to install right now some demo app, again, with a vet. So it's pretty simple. I just took the pet store one, and I'm going to deploy it on Nomad. So again, we'll go right now to the UI. What you can see is that I have that installed. So it's pretty simple, right? It's like really straightforward. I just have right now, I took Nomad, installed Gloo, installed demo application, and that's it. So the next one that we need to do is actually put route, right? I mean, we wanted to see that we can actually get to this application. So for that, oops. Come on. For that, I'm going to do cut to routes. I will be able to copy it. And what we're going to do is just copy basically the command for Gloo to actually create route. What did I mess up? Did I mess up something? Because probably. Sorry. You missed. Yeah, I will copy again. Sorry about that. Okay. I didn't use Consul. Okay, now it should work. Okay, so what you see, I immediately created a line, and the last thing that I wanted to do is probably I will port forwarding it, and I will port forwarding it and curl it, and you will see that it's working. Pretty simple, right? Right, so it's working. So that's pretty simple. I just install Gloo to Consul, and what's beautiful of it, if we will go right now to Consul, we will see, if we will go to the key value, we will see that everything is stored here. The routes and everything, and I can actually go, and the beautiful of what actually, not like CRDs, but actually the key value of Hashi is giving us is the ability to actually see this, right? It's very simple, kind of like YAML one, and I can actually browse and see everything that exists there. So that's kind of like the first one. This is with Hashi. But let's go right now and do something else. What we're going to do right now, we'll look at a different demo quick. Okay, so let's look at what we have right now. Okay, so this is a very simple application. It's a regular one. It's a hello world for a Spring application. It's actually not written by us. It's written by Pivotal, and you can see here the code and the founder, the orders and so on. And it's very simple. It's a monolithic application. It works. We can actually see everything is working. But then when you're looking at here, I have a new engineer in my team, and I really want to add another column that actually showing the location of the user. So what do I need to do right now? So it's pretty simple, right? It's a monolithic application, Spring, right? The only thing that I need to do is this. First of all, I need to learn the code. Monolithic application, and usually it's way more complex than what I'm showing here, right? The second thing, you need to add the functionality. Then you need to test the functionality. Then you need to regression test the functionality to make sure that you didn't break anything. And then you need to redeploy monolithic application. So let's look real quick how Gloo can help you. So this is the Gloo UI, okay? Now what's special about the Gloo UI? Besides the fact that it's extremely big, is the fact that the first thing that you're getting is basically understanding what's going on in your system, right? So as I said to you, discovery is something really important to us. You're getting this information. Envoy, right? You know that you have one, you know that it's healthy. If it's not going to be healthy, you will know about it, right? Because we are immediately going to show you. The second thing is that virtual services is the object of basically defining this application. So what you can see is that you have two is here. What you can see is that it's also going to show you a problem. Like for instance, here I have a Kubernetes upstream successful, but I have one static that is hurtful. I can actually come here and I can see immediately the reject. I can see why it's reject. I can see what's wrong with my system. Okay, so let's go back and actually look at what we discovered so far. So this is my environment, right? And what you can see is the Kubernetes. In that case, it's installed on Kubernetes. You can see that you can actually you see that it's green, right? So it means that it's healthy. You can actually click on this and you can see that it's accepted, so it's all good. You continue going there and you can see that there's one that is not accepted. I just put some garbage data here. And we, it's basically working, it's all good. So what we can do right now is going to see the virtual service itself. So what you will see is that the Gloo UI is actually served by Gloo. And the other thing that you can see is that I had created a default application. And if we're going to, and it's healthy, which is good, but when I click on this, I can see that's actually have one route, and this route is basically, this route is basically all going to the monolithic application. Very simple and so on. So what we're going to do right now is pretty simple. We will go back to the UI of Gloo, to the upstream, and we're going to look for this application. And what you can see is that we have 4 instances of this application. The first one is the monolithic application. I lift and shifted just because in the demo it's way easier. The second one is the database that the application is actually going and explorer. The third one is another instance of the database. And the last one is instead of doing all these things that I just described, what I decided to do is just to write a very simple Go microservices. So it's really simple Go microservices. Seriously, 100 line. That's all it's doing is going to the database, Go because that's the language that I'm feeling very comfortable with, taking the information from there and render it as an HTML. So it's pretty simple. So now what I will do is pretty easy. I'm going to add, okay? I'm going to add the Gloo the Go microservices to the default application. So I will come and I will say, please go to default application, add this Go microservices, add it to the /vet. As a prefix, of course, I can do other manipulation if I want to the routing, and it's here. So what you can see now, it's also healthy, which means it's already there. So if we're going back right now to the pet clinic, this is a Java application. Well, what you can see here, this is the Go microservice already. So basically, and you saw how quick it is. The reason it's so quick is because, as I said, Gloo is really good control plane, with 2 years of experience and crazy scale and big organization. And the other one is Envoy. Envoy is just really solid. So as you can see, it works and it's all great. So what we're going to do right now is pretty simple. We're going to come back to the contact. And we will see that also contact is not working. And I can totally fix it, but just for fun of it, let's just instead of fix it, just let's do Lambda. So every time that someone will click on this page, I want to serve a Lambda. So let's see how Gloo can help you with this. So the first thing that I needed to do, I'm just going to say before, as you can see, we can also put all the authorization and rate limiting and everything on the virtual service. So now what I'm going to do is pretty simple. First of all, I need to add an upstream because I want an AWS upstream. And creating an upstream is pretty simple. I'm coming here, I'm giving it a name. I'm basically choosing an AWS one. I'm going to choose the secret that I wanted to use, right? And I'm going to click. Now see what happened. Immediately, it created a one, but not only this, it found all the Lambda that's running there. So this discovery already managed to create the upstream, and you saw how quickly this discover all your Lambda, and including version and so on, and basically serving it. So now we can do it from here, or just for fun of it, let's do the other one from here. Just you'll see that we can do both. And basically, it will be very simple of kind of like create a route. It will come to the default one. It will be the AWS one. We're going to choose contact form tree. Now, Lambda is always returning JSON, but I really want to show you here HTML. So we created a crazy transformation filter on top of Envoy that will give you the ability to transform from whatever you want to whatever you want. So I'm going to enable it. And then I will go to say that every time that contact is being called, and add it to the route. So again, as you see, it's adding, as soon as it will be green, boom, it's ready. So what coming here is this. This is a monolithic application. This is a Go microservices. Every time that I'm clicking this button, it's spinning a Node.js AWS Lambda. So that's basically giving, okay, so it's just to show you the example, but basically that's what you can do with it. You can do with it everything you want. And glue those environments together and basically have an application that you're adding the new functionality there and basically extending. Oh, we don't have a lot of time. So that's kind of like in the nutshell what Gloo is, and really recommend you to go and check it out. As I said, it's open source, so you can go and look at it. Do we have more what to talk about? So theoretically, right now, I'm supposed to talk to you about service mesh, but I have to say that I have a 1.5 minute. That could be a little bit of hour. But I'm only going to say that last year, so like a year ago, I understood that there are going to be more than one service mesh, and people will need to support. And the reason is, like we can see right now, every cloud provider will choose a different one. Potentially, you should use them because it's probably integrate very nicely with all their environment. So now the question is, how do you glue those together? And I came with the vision of super glue. Again, I don't have time, so I will talk quick fix. After 6 months, Microsoft reached out to us and said, this is great. We love it. We want it. And we announced together what's called SMI, Service Mesh Interface. Service Mesh Interface is the ability to basically unify the language of every service mesh. We specifically also grouping them together and flattening the networking. So basically, if you guys familiar with what Mesos was doing before, which the vision of you have a lot of small servers and they treat them as one big cluster, we're doing the same thing with service mesh and kind of like flattening the networking because everybody is using Envoy. So we can actually glue them, glued them as one and said, all of this is your production environment. Use this root certificate. Talk to this Prometheus versus this one, which is your development one, so the policy need to be different and so on. So that's what is Super Glue. As I said, SMI is the adapter, the translating. We're working right now with VMware to announce another thing that it's basically the interoperability or the grouping that we're doing, kind of like the names, the global namespace of it, to be able to actually come and you don't care about the implementation. So that's coming very soon. Stay tuned. But that's basically the idea. And of course, I said with Microsoft, but the partner team that announced the SMI is us, Linkerd, Microsoft, as well as Hashi. And we're also partnering with Hashi on the one that we're doing with VMware. So that's kind of like in the nutshell. We have a product called Service Mesh Hub. You should go try it. It's free, so just download it and play with that. And that's all I have to. I have way more to say, but I don't have time. So thank you.